The same type of fluid that can do this can also do this. Why doesn't this liquid behave like water? There are two different types of fluids, Newtonian and non-Newtonian. Newtonian fluids are what you may be most familiar with. For example, water, milk, and oil are all Newtonian fluids. These are fluids whose viscosity remains constant as the force applied changes. Now, viscosity is a measure of how easily a fluid moves. So when we say that the fluid has a high viscosity, this means that the fluid will move slower. And for a low viscosity, this means the fluid will move faster. Water, the stuff we need to survive. And chocolate syrup, the stuff that goes great on pancakes, ice cream, you name it. You might already have a pretty good guess as to which has the higher viscosity, but let's take a look. As you can see, the water flows a lot faster than the syrup, so here we can say that the water is a liquid with a lower viscosity. So for Newtonian fluids, changing the force you apply to the fluid, such as gently slapping it, or hitting it, will not change its viscosity. Non-Newtonian fluids, on the other hand, have viscosities that can change as the force applied to them changes. Like earlier, it behaves differently when you apply a lot of force than when you apply a little bit of force. This is the type of non-Newtonian fluid known as a dilatant fluid, whose viscosity increases with force. This fluid here, known as oobleck, is a suspension of cornstarch in water. A suspension is a mixture of a solid and a liquid. In this case here, cornstarch is going to be our solid, and water is going to be our liquid. Cornstarch is a large, blocky molecule, which we will symbolize with rectangles in our drawings. Water, on the other hand, is a much smaller, rounder molecule than cornstarch, so we will visualize it as these circles. When we combine these two, we get a suspension. Each cornstarch molecule is surrounded by water molecules. As you can see, the water molecules are a lot smaller than the cornstarch molecules. In the event of a weak force, only a little bit of force is applied by pressing on the cornstarch with a hand. The cornstarch molecules are able to slide past each other because the water in between them acts as little balls that they can roll over. But during a strong force, when I apply a lot of force, the water molecules are pushed out from in between the cornstarch molecules. This creates an area that is almost entirely cornstarch. For the suspension to behave as a non-Newtonian fluid, the ratio of cornstarch molecules to water molecules needs to be within a certain range. If there are too many water molecules, then the suspension will behave as a liquid, and if there are too many cornstarch molecules, the suspension will behave as a solid because there is not enough water molecules in between the cornstarch molecules for them to slide past each other. In this area, there is now a majority of cornstarch molecules, so it behaves as a solid. Hitting it with my hand is practically the same thing as hitting a hard surface. There is another type of non-Newtonian fluid called a pseudoplastic fluid. These are fluids whose viscosity decreases as force applied increases, essentially the opposite of dilatant fluids. Unfortunately, it is not yet understood why pseudoplastic fluids behave the way they do. An example of a pseudoplastic fluid that is very common is ketchup. Oh yes, that tasty sauce found on burgers and french fries is actually a pseudoplastic. Notice here how the ketchup is able to retain its form without spreading out, unlike other common fluids. Here, the ketchup is being tipped over without any ketchup coming out, but when we add a force, such as hitting it, the viscosity of ketchup decreases, allowing it to slip out of the bottle and onto your burger. And now we're going to show you how to make your very own non-Newtonian fluid at home. It's easy. You'll need a bowl, some cornstarch, water, and something to mix everything along with a small measuring cup. Take about 3/4 of a cup of cornstarch and about 1/4 cup of water, and mix it up. Try not to get any on your clothes, but if you do, it will wash out easily with water. Once you're done mixing thoroughly, try to pick it up with your bare hands. And take a look. You've now got a fluid that's both a liquid and a solid. Pretty neat, right?